Hi, my name is Nick Bolu. I'm a patent attorney. This video is about the top 4 strategies for patenting software inventions. I've been helping inventors obtain patents for software inventions for almost 20 years now. And you need to take the right approach and the right strategy when you try to patent software. And the main reason for this is a law called 35 USC Section 101. And that says what is patentable subject matter and what is not patentable subject matter. And the courts have largely said that broad abstract ideas and pure mathematics are not patentable subject matter. And a lot of times software can kind of come into those categories. So you have to characterize your invention as something that the courts recognize as being patentable subject matter. So the top 4, from my experience over nearly 20 years, these are the top 4 that I think work the best. So I'm going to go through examples of all of these and kind of describe what these are, and then kind of give you some tips for how you can, use these strategies to patent your software. So I have the good strategies are 1, user interface claims, 2, input-output claims, 3, whole device claims, and 4, improvements to performance of device claims. So first, my number 1 strategy is user interface claims. And I say the benefits of these are they're relatively easy to prove infringement. So once you get a patent, if you want to enforce this against other people, you kind of have to prove infringement. And if you have a user interface, you can simply get the product and look at the user interface and, go through the screens, and you can tell if they're, infringing your patent or not. So it's good for proving infringement if you have user interface claims. The second reason I say is generally satisfy 35 USC Section 101, that law I was talking about earlier. There is a leading case in that subject for 35 USC 101 called Core Wireless, and it said improved user interfaces for displaying unlaunched applications are patentable subject matter. And then that's actually the example I have on this page I'm going to review with you. That's the patent that was at issue in Core Wireless. And then the third benefit I say is it's good for apps. So a common type of software, it's apps. It could be, an Uber app, an internet browser app, word processing app, just there are a lot of apps out there, just for all these different uses. So all of those have user interfaces. And then even if it isn't necessarily an app, it could be, a driver or something. But a lot of times, there's the system administrator configuration user interface where you configure the parameters for a driver, or, maybe you have a switch or, a router or something. So even if it's something where you don't see the user interfaces a lot, you could still, maybe have some system administrator or other user interfaces. So all those can be patented. And I say the disadvantage is only for software with UI. So that does happen sometimes. Sometimes there's softwares that, don't have a user interface. But as I said earlier, it doesn't have to necessarily be the end user. User interface can be system administrator or other user interfaces. So the example I want to go through here is US Patent 8713476, and that is the patent from this kind of famous in the patent world Core Wireless case. And the example of the invention is shown in these figures below here, figures 1, 2, 3. These are from the patent. So you can see in figure 1, this is kind of on an old-fashioned phone, and it has this app launcher. It says like messages, contacts, calendar, phone. And then we go to figure 2. So if you select messages, it says 0 new messages, create message, enter chat room. And then figure 3 is just like another interface where there are 3 unread messages, new SMS message, chat ongoing, create message, enter chat room. So if you see that create message and enter chat room, that's, launching an application from this other launcher user interface. And then this is basically what the claim was. So they claimed these user interfaces, and I have an example of one of the claims from that patent here. So it's claim 20, a method comprising displaying on a computing device having a display screen, a menu listing one or more applications. So that's over here, figure 1, we have one or more applications. Displaying an application summary that can be reached directly from the menu, where the application summary displays a limited list of data offered within to one of the more applications. So it's like this create message, enter room, and then it says, in response to a user selection of particular data, launching the respective application associated with the selected data to enable the selected data to be seen within respective application. And then that's going back to this create message, enter chat room. So I think this is kind of a good framework, for a lot of applications to work with this. You go from one user interface, you can do some selecting, you go to another interface, and, claiming these different interfaces, I think, is a good way to patent software. That's my number one strategy. My second strategy is claim inputs and outputs. So I say the benefits for this is, sometimes it's easy to prove infringement. There are a lot of times there's software documentation, there can be technical specifications, and you can also test software. So if it's a driver, middleware, if it's an API, there'll be some kind of documentation about how you can use that. And that'll kind of say, what the inputs and the outputs are. So you can kind of go to the competitor and look at this kind of documentation, and you can see if someone is infringing your patent. So it can sometimes be easy to prove because people, they kind of say what the inputs and the outputs of their software are. And I say this is good, again, for like APIs, middleware drivers. Again, the user interfaces are kind of the go-to strategy, but if for some reason, if that's not a good strategy, this input-output strategy is good. Disadvantages, sometimes difficult to prove. So yeah, if you're just looking at input outputs and there's not good documentation, if it's not quite clear what's going on, it could be more difficult to prove than just, looking at a user interface. And then I say, another disadvantage is if same inputs and outputs as other software could have difficult patenting just inputs and outputs. So that's realistic. So a lot of times, sometimes you could have a software, you have the same inputs and outputs, but the processing you're doing in the middle of the software is kind of the novel part. But your inputs and outputs are the same. So if that's the case, then this strategy doesn't really work as well. So this is just another, this is a example I have here. It's US Patent 10469314, and it's a patent for an API. So you can see this figure 2 on the left. There's a corporate data center, there's AWS cloud, and then there's users. And this is for an API between the corporate data center and the AWS cloud. So the 208 in figure 2 is the API. And then the figure 3 kind of goes more into detail about the API. It's showing, kind of the inputs, outputs coming out of the box. And, it's showing some of the computing within the API. And this I'll just quickly go over, the claim they had there. So it says a method comprising intercepting an extended public cloud API request at an API gateway for network policy and configuration management with a public cloud environment, searching a data store using an extensible attribute as a parameter in the extended public cloud API request, obtaining a next available IP address for a network matching a virtual private cloud subnet identifier, processing the extended cloud API request, and translating the extended public cloud API request into a native public cloud API request that specifies an IP address, and sending the native public cloud API request to the public cloud environment for processing. So you can kind of see here where it's, it's kind of the API, you're having this request, you're doing processing, you're translating into a native environment, and then, you're sending the request on. So this is a good, example of, patenting inputs and outputs. Strategy 3 is to claim the whole computing device with new functionality. So benefits, you generally satisfy 35 U.S.C. 101. In this case, you're like claiming a whole electronic device like a computer or a cell phone, a tablet, a router. I say this is good for new functionalities, functions, capabilities. Disadvantages could be claiming more than necessary for novelty. And, I think when this is mainly, let's say you have a router or a Wi-Fi access point or something, inputs to outputs are saying there's not a lot of good user interfaces. You're kind of providing new functionality, but a lot of it's internal processing that may not be 35 USC 101 patentable subject matter. So I think in these sort of cases, when the device as a whole has new functionality, you can claim the whole device. And the example I have for this is US Patent 464652. This is kind of a long claim. This is for the original Apple Mac interface. And the interface, you can see this is kind of an older patent. I have an example, figure 14, and you kind of see how they have like a menu bar that's T1, T2, T3, T to the N across the top. And then you go down to that and you have cut, paste, insert. So you can kind of scroll down and pick one of those and, do launch applications. Honestly, like this could have maybe been like just a UI case, but if you look at the claims in the case, they're actually claiming the whole computer. And this is an older case, so maybe it's they thought it was more necessary for 101 issues to claim the whole computer at this point instead of the user interface. But I'll go through this claim, but you can actually see it has like the mouse and the display screen on the computer. So they're claiming basically the whole computer for this. So let's see. So example, claim 9. A computer-controlled display system having a display wherein a plurality of command options are displayed along a menu bar. So that's this T1, T2, and sub-command items corresponding to each option are displayed once said option has been selected. So that's this cut-paste, this sub-menu items. First display means coupled to said computer for generating and display said menu comprising said plurality of command options. So we're saying said computer, so we have a computer in this claim. And then we have display means, so that's claiming the display right there. The next element is we have cursor control means coupled to the said display system for selectively positioning a cursor on said display. And then there's more about moving the cursor. So that's basically, claiming the mouse. Signal generation means including a switch having first and second position coupled. That's again kind of going towards the mouse and some switch buttons. Second display means generate and display sub-command items, set switch being placed. So that's again going back to the mouse, whereby an option is sub-command. So if you look at this claim, we're kind of we have the computer, we have the display, we have the mouse, we have some UI stuff. So we're just claiming this was claiming the whole Macintosh computer. And, you can see obviously the limits for this. If you had a touch screen or if you just weren't using this mouse, if you're just doing some kind of vision system, there's a lot of ways you could kind of design around this by not including this hardware. So that's why I say the disadvantage is you could be claiming more than necessary for novelty, because when I view this, I think the UI was probably the novel part here, but they're claiming the whole computer. But sometimes that's why this is option 3. I think those other options are better, but if you need to claim the whole computer, then that's okay. Strategy 4, claim improvements to performance of computing device. Benefits generally satisfy 35 USC 101. I say this is good for improvements to performance of hardware. Disadvantages could be difficult to prove infringement. So this is, I think, good for cases where, sometimes if you just have internal processing of a computer, it's just processing 0 and 1s, that's not having a lot of big impact on the outside world. It can be more difficult for 35 USC 101 if nothing's happening, basically. But what can be happening is you're improving the performance of computers. So you could make the computer run cooler. You could be more efficient by using less, CPU resources, by using less memory. So if there's something that's kind of internal, doesn't have a UI, doesn't really change the inputs, outputs that much, not a lot of new functionality, but it's just kind of improving the functionality computer, then I think this is a good strategy. So I have an example here. I think this was a memory system. It's a US patent 9432298. It says system method and computer program for improving memory systems. And then I have an example claim 7 from that, where it say transforming a first memory command or packet, then transforming a second memory command. So a lot of times when you just have these transforming, the patent office and the courts can view this as just kind of math, kind of an abstract idea where nothing's happening. But if you're improving the performance of a computing device, memory, bandwidth, processing efficiency, that sort of thing, then this is kind of a good strategy to use. So summary recommendations for patenting software inventions. So practical tips. So I say identify a novel, interesting, or valuable part of software. So is the valuable part a user interface? Is it input output? Is it a new function? Is it the performance of a computer? So based on where the novelty is, it kind of maybe it's all of these. And if it's all of these, I think the UI is still a good way to go because it's easy to prove because you can just pick up a competitor's device, see that it's infringing. It's easy to prove, and then there's a lot of law saying that it's 35 USC 101 patentable subject matter. But then you can kind of go down, if that's not a good choice for you, you can look at input outputs. Sometimes they have, technical documentation. You can look at new functions. You can look at the performance improvement. I say practical tip, avoid broad abstract ideas and avoid pure math, So if it's a little difficult if you just have a new algorithm and it's just processing within a computer. There's no inputs, outputs. It's not really doing anything. If you're just translating one set of numbers to another number and not really applying it to anything, that can be difficult to get a patent for. So you kind of need to, even if that's what you're really doing, the main part of it, there may still be novelty in one of these UI/IO, new function performance or something. So it's kind of better to go for that. So those are my tips on patenting software. My contact information is listed on the right. My LinkedIn is here. If anyone wants to connect on LinkedIn, please feel free to connect on there and stay in touch. And then my law firm bio page is here, and then also my Gmail. So if anyone has any questions, feel free to contact me at one of those. So thank you for watching this video.